Hey everyone, welcome back. Today, we're going to break down two ideas that are, no joke, the absolute bedrock of how most software is built. These concepts let us represent literally anything, from a character in a video game to your bank account right inside a computer. So let's dive into the world of attributes and methods. But before we even touch a line of code, let's start with something we all get. How would you describe a dog? Seriously, take a second. What pops into your head? Is it the breed, its name, or is it the things it does? Like barking or wagging its tail. This one simple question holds the key to everything we're about to talk about. So here's our game plan. We're going to start with that dog description and use it to build a kind of blueprint. Then we'll see how that blueprint translates into the real programming concepts of attributes and methods. After that, we'll see what it all looks like in actual code. And finally, we'll wrap up by looking at why this way of thinking is just so incredibly powerful. All right, let's get into it. Section 1. A blueprint for objects. We're taking our real-world idea of a dog and breaking it down into its essential parts, the kind of parts a computer can actually understand. Now, what's really interesting here is that your description probably splits neatly into two different categories. On one side, you've got properties, the things a dog is, like its breed, its age, its name. This is its state of being. And on the other side, you have behaviors, the things a dog does, like bark, or eat, or sleep. These are its actions. This fundamental split between what it is and what it does is the big idea behind so much of modern programming. Okay, so let's zoom in on that first category, the what it is part. In programming, we have a specific word for this, which brings us to section 2, describing the state with something called attributes. An attribute, it's really just a piece of data that describes something about an object. That's it. Our dog's breed, its name, its age, those are all attributes. And in the world of code, we store these pieces of data in things called variables. And here's what that actually looks like in code. To store the name, which is text, we'd probably use a data type called a string. For its age, which is a whole number, we'd use an int, which is just short for integer. So you can see how each property we came up with now becomes a specific, defined attribute in our blueprint. So we figured out what a dog is. Now, what about what a dog does? Well, this leads us perfectly into section 3, defining behavior with methods. Just like an attribute is a variable for holding data, a method is a block of code that performs an action. If you've ever heard of functions before, it's pretty much the exact same idea. A method is just a function that belongs to an object. It's the doing part of the equation. And here's what they look like. The action of barking becomes the bark function. Wagging its tail becomes the wagtail function. See those parentheses at the end? That's the classic sign that you're looking at a method, an action just waiting to be called on to do something. Okay, so we've got our attributes for the data, and we've got our methods for the actions. For section 4, let's put it all together and see what the whole blueprint looks like in a real programming language, like Java. In programming, we call this blueprint a class. A class is like the master template, the container that groups together all the attributes and methods that define what a dog is and what it can do. And here it is, the blueprint brought to life. Inside our dog class, you can see we list the attributes right up top, the breed, the age, the name. And then right below them, we define the methods, the actions, like bark and wagtail. See how it's all bundled together? All the related information is in one neat, logical package. So why do we go through all this trouble, right? Why not just have a bunch of separate pieces of data and actions floating around? That brings us to our final section, and it's a big one. Why this structure matters. This is all about the power of what we call object-oriented design. The benefits are huge. First, organization. It's just clean. Everything that has to do with a dog is kept together in one place. Second, reusability. This is a game changer. With our dog blueprint, we can create thousands of different, unique dogs. Buddy, Lucy, Max, all without rewriting the core logic. And finally, predictability. We know for a fact that any object we create from our dog class is going to have the same set of attributes and methods. This makes our code so much easier to manage, especially as it gets bigger. And that really brings us to the final idea. Think about it. A car has attributes like color and speed, and methods like accelerate and brake. A user account has attributes like a username and a password, and methods like log in and log out. Once you start seeing the world this way as a collection of objects that have things they are and things they do, it totally changes how you think about building things. So the only question left is, what will you build?